Thank you very much. Hi, I'm Dominik, and I hope we also become to be cyberpunk. But let's see. We have a little bit of a different approach. Yeah, I'm here to talk about how we approach privacy in Maiden. And I want to say that our initial idea was that privacy, even though it's an end goal for us, it's also a means for scalability. And this, from a high level, makes sense, at least like in terms of blockchain. So if you don't tell the blockchain what you're doing, then the blockchain doesn't need to re-execute it. The blockchain doesn't need to store the state because the blockchain doesn't know the state. And then if you could build a blockchain that is private in the sense that execution and the state stays at the edge with the user, then the blockchain is much leaner and way faster, and in that sense scales way better. But like what do we want actually is that 1,000 of users transact at the same time, some in parallel, maybe even millions, and we want that Alice doesn't see. And this is only possible since zero knowledge proofs become so fast, maybe since 2 years or so. The transaction at the edge and store the state at the edge, and then we can build a blockchain around that. So, but like ZK doesn't give you the whole concept basically, so we needed to rethink the state model of a blockchain and apply the actor model, and that allows us to transact at the edge. And for privacy, we can use client-side zero-knowledge proofs that allow us that the data basically never leaves the user's device. Just a refresher, the actor model, you can think about actors are little state machines within boxes. So you have a network or a database with a lot of these actors, and they communicate via message passing. So they send messages to each other, trigger state changes, and this can happen asynchronously, or this happens asynchronously, and therefore it can happen in parallel. This is like a model how it could look like. So if you can build a blockchain around this model, and these actors, like message, like creation of a message and the consumption of a message would be proven by a zero-knowledge proof, then you get scalability and privacy for free. And so we apply the actor model on Maiden in the sense that we have accounts, and accounts are working the same way as on Ethereum, so they maintain state and they expose methods, or they have certain code. Every account is a smart contract, and they create nodes, and these nodes can carry assets, and they have certain spend scripts or spend conditions, and you need 2 transactions to transfer an asset from one account to another. So in a first transaction, account 1 would create a node, and in the second transaction, account 2 would consume this node. And this is because we define a transaction as the state transition of a single account. And here again, if you rethink the actor model, so you have these little actors, they receive messages, change their state, and send messages out, and like this is a transaction for us. So when one actor changes its state, we can prove that independently from the other actors, and therefore we need 2 transactions to transfer an asset, but our accounts can change their state in parallel. And all accounts are smart contracts with code and storage, and we can store any asset in the account. And the same for nodes. Like nodes have, like they are little smart contracts, so to speak, but or if objects, so they also have code. And when you need to execute this code and create a zero-knowledge proof about it, and can multiple assets. And this is how we, like basically our protocol works. When you understand what a transaction is, I always say that like you have 80% of the protocol. A transaction is just the state transition of a single account. So basically it's some kind of program that gets a stateful object like account 1 in and results into the account 1 in a new state, and it can consume up to 1,000 nodes and produce up to 1,000 nodes, and this is how we define a transaction. And this is different to, let's say, on Ethereum, where you can have a transaction where Alice sends something to Bob, right? And you need to change Alice's account and Bob's account at the same time. On Maiden, it's always only one account, and that's why you need more transactions to transfer an asset, but you get parallel execution. And if you do it client-side, you get privacy for free, because all the network knows is just that a commitment to a certain account state changes. And this is actually the topic of my talk, but I explained the protocol quite quickly, and then I can talk more about privacy. But the thing is, every transaction, so every state transition of a single account, always gets CK proven. Like with the Maiden VM, it's like a Stark-based virtual machine, but we can basically prove the transaction of every account. And with this, like the data stays on your computer. So all the network knows about this transaction in the normal case is just that a commitment to this account changes on-chain. And these dark proofs can be generated in parallel. So what we have basically is the more private the network is being used, the better it scales. Because like we also have network transactions, or if like we have smart contracts with public shared state, but there you need to change that again sequentially. However, if you just do a normal transaction or like a private smart contract, then all the network needs to change is this commitment to a state, and this can be done way faster and way leaner. So in our system, and this is like a paradigm shift to what we have on Ethereum or on other blockchains, like when you add privacy or you use Maiden in a private way, it just like is cheaper and faster. And like when you compare it to Ethereum, for example, when you want to add privacy to a transparent chain, I mean a chain that works by transparent chain verifies transactions by re-executing them. So you need to add privacy on top, and need to encrypt something on top, or you need to somehow hide information. But this is always way more complex and way more expensive. That's why like Tornado Cash is more expensive than a standard Ethereum transaction. Or like when we add MPC in the end, or when we run some Ethereum transactions in a TEE or whatever. So when we want to add privacy to a transparent chain, it's always way more expensive. Whereas on Maiden, it would be the cheaper option. And so what do we know? So Maiden looks a lot, was inspired heavily by Zcash. Basically, we also have these three databases, or like Zcash doesn't have three databases, but we have three databases, like with an account DB, nodes DB, and this nullifier database. And this is how we achieve privacy on Maiden. And this concept is from Zcash is with this nullifier. But like the accounts can be stored publicly, so with the full code on chain or privately. And then all the network knows is basically this hash. So the account with the orange circle here is just like a commitment to the state of the account. So every account on Maiden you can think of is its own validium, or like no one knows what's behind this commitment, but you on your local machine know what's behind it. But you can also store your account when you want to build DEX, for example. You can also have public shared state. And the same is true for nodes. So you can build a public node, and then the full node data would be on chain, but you can also have the node private, and then the commitment, only the commitment to this node would be known by the network, and there's no more data. So even in the future, it cannot be decrypted. It's just a commitment to this private node, and if I want you to consume this private node, then I can send you the private node data via Signal, or we create a private transport layer via WebRTC, and then you can consume it, but only you and me, we would know about it. In theory, we could even create a system with this that not even the receiver knows who the sender is, but more on that later. And yeah, like to create this, we have like an append-only accumulator where I can always add nodes. This is, we need that for parallel transaction execution, or such that I can have this node DB basically also like a slightly older version, and it would still be true for my zero knowledge proof. And I have this nullifier database that basically keeps track of which nodes were already consumed to prevent double spend. And this, I don't know, like if you're familiar with Zcash, it's also in Zcash or Aleo or Aztec, they also have this kind of nullifier data structure. And so now the topic of this, basically, we will gradually level up privacy, and I would be interested in your opinions on that. We discussed it quite a lot. There are other systems, they go for privacy from day one, basically. And but we see privacy as a spectrum. And so level 0 would be that everyone sees everything, so we would basically have no privacy when you look at, I don't know, Ethereum today or even Bitcoin. Level 1 privacy would be when I use PayPal today. So the transaction participants know about it, and the people who work at PayPal, or maybe people who have access to that. But like Bob would not see what Alice is doing if Bob is not in this PayPal realm. Level 2 privacy would be strong privacy, which would be what we wish for, that only the transaction participants see everything. That would be true for cash, right? So if I give you 100 euros in cash, then we would know about it, but no one else. And this would be something we want to achieve. And level 3 privacy is that everyone only sees their data. I would send you money and you don't know that it comes from me. I don't know if there's a use case for that, but that would be the end of the spectrum. And in theory, we can build this with client-side proofs as well. But just a reminder, how does it work on Zcash, or in that case on Maiden with this node hashes nullifiers? So how can I ensure that if you consume a node, that we cannot somehow detect it and say, okay, you consumed that node, so it's not private anymore. Basically, we have these two transactions that we need for a transfer of assets. So in a first transaction, account 1 would create a node that contains 100 ether, and then there is a node hash, basically a commitment to this node that we add to this node database. And in a second transaction, account 2 would consume this node, and it would record a nullifier, or like it would create a nullifier, compute that, and push the nullifier to the nullifier database. And the nullifier and the node hash, they are not linkable, meaning that if you don't have the full node data, you cannot compute both, because it's just like a hash of a different subset of the data. And so only when you have the full node data, you can compute the nullifier. And that's therefore like you don't see that a certain node is consumed. So you only see that nodes will be added to the nodes database, but not which nodes are consumed. At least on the protocol, this is privacy preserving, as we've heard in other talks. Obviously, like when you have like a small set of sequencers or so, they could track the IP, and there could be some links with time, and like this can be solved, but not on the protocol level so far. So now our problem was, okay, so in theory with this protocol we can achieve a handy level of privacy, but what do we want to provide in the beginning? And we decided to go for level 1, web 2 privacy, basically that the transaction participants see everything, and like our centralized sequencer with which we start would also see everything, at least for the first 2 years. And I know this is not very cyberpunk, but what do I mean by that is like this is how a private node looks like in Maiden today. So you don't really know what's inside. You just know that there is a private node with this node ID or the node hash, but you don't know which assets are there or to whom it is directed. And we don't know the nullifier. We don't know if the node is consumed or not. And at the moment, we track the sender for debugging purposes, but this is actually protocol-wise, you don't need to know the sender. But why do we do that? So why are we going for what we call pragmatic privacy? Basically for two reasons. So one major issue that we have is debugging. And I don't know how other systems do it, because I know that Aztec, for example, is launching like fully private in a decentralized mode. But our problem is that like in these zero-knowledge virtual machines, this is super experimental software. Like what happens if there's a soundness bug? And I'm pretty sure like in all ZK VMs, like there are 25 out there at the moment, there for sure will always be a soundness bug. At least we found a couple of them in Maiden when I was in Polygon, also in the ZK VM zero-knowledge virtual machine, there were a lot of bugs. And the problem with a fully private network and a soundness bug is, like if someone finds that bug, they can print infinite money and you will never know about it. Like you wouldn't even realize it. Like it's just like there's one person getting richer and richer, and then they would leave the network, but you could not even identify it as a bug. And so at least for debugging purposes, at the moment, we have this kind of centralized entity that gets all the transaction data and can in theory rerun them. Which helps us for debugging. And in the future, we want to obviously also become decentralized and get rid of that. But this was one reason why we start with this pragmatic privacy. And the other reason is indeed regulation. So when we decided that, it was like another administration in the US. There's this EU regulation. I don't know, like Amin was talking also about it today, that the EU tries to prohibit or prevent privacy coins from 2027 on. So actually it's like I don't know if this will happen or if we can do it even without the EU, but the problem is like it's a super uncertain regulatory environment at the moment. And like in theory, we can make it a switch and become fully private, but at least in the beginning, we were unsure if we can sustain as a project, if we would start as a fully private project. And so we decided to have this pragmatic privacy. And so at the beginning, like this will be our approach. We offer this Web 2-like privacy, but the system can do way more. And I'm personally like a huge fan of privacy. So, or like this is also what drives us. So I hope in 2 years we can become real private. But would be happy to hear your opinions on that, or if you would do it a different way. Thank you.
We're running out of time. Maybe just one question, because it would be nice to share an opinion. Okay, I will ask. If you're unsure right now what kind of regulations will be, how you approach even the state of regulations in 2 years, in 3 years, you will be always kind of like play safe, sort of? Like what's the internal thinking process behind it?
Yeah. That's a good question. Actually, we don't know. Like, or we were approaching this, like in the beginning, it was a research project. It was a super fast zero-knowledge virtual machine, and then we built a blockchain around that. We even were in contact with from the EU Commission or the Brazilian Central Bank or so, and they were interested in this. But we also like in contact with people who want to use it fully private. And at the moment, we are trying to find out. What we want is we want to keep working on it, and we have 25, 30 people now in the team. And so at the moment, this pragmatic way was the safest for us. But we tried to talk to people, obviously, also like in Polygon. It was a very good compliance team, so to speak. But it's also hard, like we are not big enough to hire lawyers that would work on all the jurisdictions. And so we are not sure yet, actually, what to do. But